thank you for being here. I know it's lunchtime, so it's difficult to compete with food, but I really thank you for being here. Today we're going to talk about a couple of interesting topics. To be honest, this presentation is like one of the most exciting presentations I've done in quite some time. You'll see why, but we're going to talk about the entity component system mostly, the burst compiler, and the job system that comes in Unity. But the title here is just ECS. The title on the agenda is like the future of high performance scripting, which could be the same thing. So first things first, I want to show you a quick demo. Probably you've seen this one, and it's a shame that Unite Melbourne is just like 3 days before Unite LA, because Unite LA, which is taking place in a couple of days, will feature a lot of new demos that are super cool. But yeah, I have to stick with this one for the time being. Probably you've seen this one. This is a game called Spell Souls by a team called Nordeus, and it showcases a couple of interesting things. First thing is, my mouse is working. The first thing is you can see how many objects I have running here on my game. You see I have 16,000 units, almost 17,000 units, and it's running at 30 frames per second. Another cool thing is that this is running, but I'm also running 2 extra instances of Unity. Like I have Book of the Dead open here, and I'm still getting that frame rate, which is it's mind-blowing. Okay, but that's not the point here. So I have that amount of units. As you can see, if I get too close to them, maybe not too close. These individual units are objects. They're moving around. They have like a small AI script that moves them around, tells them where to go, tells them when to start fighting. We have a couple of simple animations. These animations are not like skinned animations. It's a different technique, but you get the idea. I'm not going to cover that today. But you see, like we have a lot of these objects here, right? But maybe 17,000 is not enough. Let's see if I can bring it up to 64,000 objects. You see that the frame rate is not the 60 frames per second I had before, but still I have 30 frames per second, which is above of what usually you want to target, especially in a small computer like this one. Probably when you're playing or when your player is playing your game, they won't have 3 instances of Unity running, one with Book of the Dead there, right? So you get the idea. This is what we're trying to achieve. These are the type of tools that we want to give you as developers so you can create games that are more performant. So if you're targeting, Jay mentioned this on the keynote, like we have this new Unity, a small runtime. If you want to target like these devices, if you want to go after mobile, and you want to reach people with devices that are old or with small memory or a small processor, then you can. If you want to target like high-end PCs, high-end consoles, etc., you can, and you can have this amount of crazy objects. Oh, I thought Unity crashed. Oof. No, Unity never crashes. So let's go back to the presentation. So yeah, that's what we want to achieve. My name is Arturo. I'm an evangelist at Unity Technologies. I work for the Americas, but I come from Mexico City. So this is as far as I've been from my home ever in my life. It's pretty amazing. You have an amazing country, an amazing city. I still need to see some kangaroos walking on the street, but hopefully today or tomorrow. If you have any question, you can always send me an email, even if it's related to this presentation, if it's related to something else. I'm happy to try to find an answer for you always. That's my Twitter account. If you want to follow like Unity stuff or weird stuff, like weird pictures or something, then this is the account you want to follow. So ECS, who here is familiar with this concept? Raise your hands. Okay, cool. I will say like 10% of the people right now. So 90% of the people here will learn something new today, which is amazing. Okay, so first things first, E stands for entity, C stands for component, and S stands for system. That's all we need to know today. So yeah, we can go grab lunch. Yeah. No, the first thing we need to think of is what do we want to achieve, right? Because the thing that we're going to see today is a paradigm shift of how we code our games today, how you go to the Unity documentation and how you see the code snippets there. So it's a paradigm shift. So why do we want to do a paradigm shift? So first we want to understand what we want to achieve. And what we want to achieve is performance, right? Probably you've seen like Twitter Unity keynotes, or you've seen like Unity on Twitter or on Facebook or our blog posts. And most of the times what we are showcasing lately is the fact that we want to go after performance and after after being the best rendering out there. So those are one of our main goals. You probably have seen this title, Performance by Default. This means that we're working on making Unity as performant as possible. So even if you don't want to switch like to the ECS paradigm, you don't have to. Unity will still be as performant as possible. We'll see that in a second. But also, if you want to create performant code, if you want to take your code to the next level, if you want to achieve something like the project I was showing before, where you want to have like thousands of objects on screen, or if you're working on a simulation and you want to simulate like fluids or something, then you can. We give you the tools so you can write this code. So remember the entity, component, system. There's going to be a test at the end of the presentation, so be sure to remember what this is. So how do we code today? And when I say how do we code, I mean how do I code? Because I don't know how you code. Who here is or was a C programmer? Raise your hands. Okay. Who was or is a C++ programmer? Okay, more people. Who is a C# programmer? Way more people, awesome. So you understand what OOP means? So this means Object-Oriented Programming. Some of the languages I showed you are languages whose main paradigm is Object-Oriented Programming. Basically, this means that we're going to model our programs the same way or in a similar way of how we see the world, right? So imagine I have, yeah, that's the thing. There's also approach that Unity encourages. If you go to the documentation, that's how we tell you or how we recommend you to write your code, right? Which is component-based. The Monobehaviour, probably if you've created any script at any point in your life in Unity, you are using the Monobehaviour out of the box. So the object-oriented programming approach is similar to this. And I was mentioning, like, this is how we usually see the real world, right? So I have a vehicle, and then I say, okay, I'm going to specialize that vehicle. So I can either go with a water vehicle, a ground vehicle, and I can specialize it a bit more. And this is how I'm going to code my program. I will be creating a vehicle class, another class that extends the first one, another one that extends the second one, and is going to extend the first one. So this is how we usually model our games if we're on the object-oriented programming paradigm, which C#, the language that Unity uses for scripting, supports. If you're using the monobehaviors, this is usually how it works. We have a root object, we have this node object that doesn't do anything. If we want it to do something, then it want it to move. If we want this object to move, then we add a script or a component that makes this object move. I can have another script that just holds properties, etc. That's how we go with this approach. If I like this approach, so again, back to the first point, why do we care? Why do we care about changing the way we write our code today? If there's nothing wrong, and in reality, there's nothing wrong. There's nothing wrong with this, but there's one small problem. The problem is, again, we're modeling our programs, our games, based on how we see the real world. Probably you get the idea by now that our brains, or how we think, how we solve programs, is different from how a computer, even if it's a PC or a console or a mobile device, how a computer sees the problems, right? It's a different way. Thus, you get the idea that the problem is that data is everywhere. That's the main problem. Okay, that's basically the reason of why we're doing this ECS thing in the first place. So let's see an example. See that I have, this is the memory. This is not a real memory layout that you will go to the, I don't know, to the IEEE webpage and you'll see this is a memory that exists out there. It's just an oversimplification of the problem, so just for us to understand. So imagine this is the memory in our game. I'm running my Unity game, and I tell Unity, okay, I want to instantiate this minion, which is not a minion from the DreamWorks movies. Although now that I see, I think I used the same color, but that was unintentional. So I want to instantiate one of these minions, and Unity will request a memory, or will create the object, and will return us a reference to that object, right? The memory is somewhere, but it's there. Then I want to instantiate another one, and Unity will instantiate for us, will return the reference, but we don't know where in memory this object is. So we're starting to see a problem here. I do the same, I get another reference, but we don't know, and we don't have any control over where this is going to be located. And the problem is that, well, first, when the processor needs to do some transform, let's say I want to move my minion using its position and its speed, okay, I need to go and fetch that data from somewhere in memory, but there might be a chance that the data, that the next frame, or even the same frame, I need that data again, but the processor already said, like, I don't need that data. Oh, but the next step, I need the data again. So it's going to request the data, and we don't know where that data is. So that back and forth is taking cycles that you could be using doing something else, right? Like rendering or physics or whatever. So this is a problem. If you want to know more in depth about similar problems, I will suggest you to do a Google search for cache misses, which is basically what I'm showing here, but you will get a better explanation of what a cache miss is. But that's basically the problem. So if the processor is starting to do this thing and not getting the data in an optimized way, the end user, your player, what they will be seeing is that the cell phone is going to get super hot because the processor is working, and you may be draining the battery as well. So you don't want to have those problems, right? So usually we think, okay, the problem is the data is like anywhere in memory. How do we fix it? Maybe we can fix it using arrays, right? And in reality, it's not a real fix because the memory, the memory layout, it's still randomly anywhere in this memory, the objects. So the arrays, the only thing that they kind of fix is that it's going to be easier to iterate over them, over these objects, but just like on the programming side, internally it's basically the same problem. So we need a way to access and save this data in an ordered way. That's basically how we're planning on fixing this thing. So imagine we have a list of positions and a list of speeds. The first one, it's going to be a vector 3. The second one is going to be a float, right? These two things doesn't resemble an object, right? If I see these two lists, it's like, okay, I have two lists, but what are they? And this is going back to the point where I was telling you, okay, we model our programs similar to how we see the world. Well, this is modeling our programs, modeling the data, modeling them in a way that it's easier for the computer or the cell phone or the console to access them and process them, okay? So if you see here, I have just two lists, and this could mean that this is a minion, basically, right? If I want to move these minions, not render them, not doing anything else, if I just want to move them, then this data tells me, okay, this is an object. It doesn't even need to be just a minion. Any object that I want to move in my game could have a position and a speed. So I could have positions and speed for everything that will move in my game. So this is the idea behind that. DoD, does that ring a bell? Raise your hand. Okay, there's something, and this is interesting because the whole ECS thing is not something that Unity is inventing. It's something that it's been around for quite some time. Even there are some implementations for Unity, not made by Unity, about the ECS paradigm, which in reality is the data-oriented design paradigm. Okay, so we're going to model our programs based on the data, based on whatever it's easier for the computer to process, which at first sounds weird because and Unity always wants to give users the best tools, the easier tools to work. We want to get there, but at the moment, it's like a shift that is going to take some time. So yeah, this is what we want to get. We are designing based on the data, not in the real world. So ECS, entity, it's an index, okay? Let's see that. An entity is going to be an index. It's not going to be necessarily a game object, because there are sometimes confusions about a game object being an entity. An entity could even be an iterator inside a for loop, a while loop, or whatever. So just think of an entity as an index, right? A pointer, not necessarily a real pointer in the programming way of thinking, but just a pointer to something, right? The component, remember, the C of the component is just the data collections, okay? So we will have collections of data, collections of floats, collections of vector trees, collections of meshes, collections of everything, right? We're going to have that data in a layout that it's easy to fetch. And the system is what transforms that data, okay? These are the concepts behind the ECS thing. Okay, so back to the vehicle example. The entity is going to be maybe just a reference to different cars, just to say, okay, this is the car one, which is going to be on the position one of the list, or whatever. We have the component, remember, that's the data. So we have our two lists, one list of vector trees and another list of floats. So this is just the data. This data by itself doesn't do anything, doesn't have any behavior, which it's also a cool other thing. And we have the system. The system is the thing, is the code that transforms that data. So that system will use this data, and it's going to transform that data, okay? This is basically the whole idea behind the entity component system. Okay, before going to the job system, let me show you a quick example of how this works in Unity, okay? So first things, if you need to be on Unity 2018 to use the entity component system, you have to get the entities package. And I use the time to ask you, have you used the package manager? Raise your hands. Have you heard about the package manager? Okay, almost the same people. Okay, just a quick add here. We're switching, apart from what I've been telling you, we're switching from having a huge monolithic engine to just splitting features that everyone needs and bundle that into the Unity engine. Anything extra, for instance, if you are making a 3D game, you don't care about the 2D tile maps, right? So it doesn't make sense to tell people, everyone, to download the tile map. So what we're doing is we're splitting like the engine. So most features will just fit as packages. So in this case, if I go to Window, Package Manager, you see here, I have a list of packages that I have in my project. One of them is the entities package. If you don't have it in your project, you will need to just install that package there. And here, if I go to All, there's a list of available packages that I could fetch to use in my game. This is interesting because, again, if I'm not using AR or I'm not using 2D, then I don't need to bring that into my project, which makes the projects and Unity itself more modular, right? So I was here because I want to mention that you have to grab the entities package from the package manager. That's the only thing you need to do. From time to time, we push updates. So I don't want to update. I didn't want to update yesterday because things could go wrong. So yeah, that's why I didn't do it, and I'm not going to do it right now. But just also bear in mind that this is a preview package. This means you can use it. It's going to be changing from time to time. So don't plan of releasing your game using the preview package or any preview package. It's just if you're interested in see how this is evolving and things like that. But in reality, we don't recommend you to try to ship a game with a preview package, although you might be able to do so. Okay, so I have my package there. Let me just open one of my scenes here. So I should have opened Visual Studio 2. Just 1 second. Are you Visual Studio users? Raise your hand who uses Visual Studio. Okay, cool. Rider? Who uses Rider? Monobehaviour? Word? Anyone? So, okay, let's see. This is an object-oriented way of making our code in C#. As you can see here, I have my class, drone. I will have all the data here and all the functions that I want every drone to use. And then the next step is to make specializations of this type of drone, right? So in this case, I'm creating a flying drone that extends drone, and I'm going to create other data and other more code that extends my original drone. That's how you do it, not necessarily in Unity, because not a lot of people uses like pure object-oriented approach in their projects, but that's usually how you see it. And I'm mentioning this because also, and I'm not sure if in Australia, but at universities, when they teach us how to program, they usually tell us object-oriented programming is like the best thing in the world. And we spend 4 years learning object-oriented programming. And if we go and buy books, we see object-oriented programming. And at any point, we don't even say like, is this like the best thing to use? We just say like, yeah, well, that's what I know. That's how I've been doing stuff. So I'll keep using that. Okay, so that's one challenge that we all have and that Unity has is that, okay, most of our users are used to use this paradigm. How do we help them shift if they want to in an easier way? For that, we started working on something called the hybrid ECS approach. Basically, and you know, not all the Unity systems are ECS ready. Like for instance, the rendering system in Unity is not ECS-fied. The physics system is not as well. So it's difficult to create a pure ECS world in Unity, given that we don't have the entire engine as an ECS ready thing, right? If you wanted to just use ECS, pure ECS, then you will need to create your own physics engine right now, which is something we don't want you to do, right? Like we just want to use something that already works and then just use it as it is. Okay, so that was the object-oriented way, which I'm just showing here. There's another way, and this is the classic Unity way of coding, which is having our monobehaviors. So as you can see, I have my I have this drone over here. And I have this drone movement script, which basically the only thing that it does is moving the drone in the y-axis. Not super complicated, just moves the drone, right? This is how we usually code our games. I have also another script for the propellers. It just rotates the propellers around. Nothing super fancy. The idea is to see how this code is usually programmed. So you see here, I have my monobehavior. I attach that monobehavior to my drone. But I have two things here. I have the data, and I have the code that transforms that data in the same script. So they are tied together. At some point, I might add I don't know, like a boat object, and I want to move that boat, and that boat could easily use the same update, the same movement function, right? I could reuse that code because basically I just need to tell where this object is and where it's supposed to move the next frame. So that's how this is working in a monobehavior way. So if we want to go to ECS, then we need to split our objects, right? We need to split them in the component, just the data, and we need to split them in the system, which is what is transforming the data. The entity itself, right now, it's just another script that comes with the entity package. And right now, it's similar to the game object. Just remember, it's not going to be the game object, and it's not the game object. But yeah, it's kind of confusing. But anyway, I'm going to open the drone hybrid scene here. It's a different scene, although it looks the same. It's still moving. So you see the drone behavior is not changing at all. Let's see, if I select my drone, you can see here that a couple of things changed. I have this game object entity script. It comes with the entities package. If you want your objects to be seen by the ECS world in Unity, right now you have to add the game object entity to those objects, right? This is the way to plug them right now. The goal is to have this pure ECS world, but right now we don't have it ready, so this is the way to go. Okay, I have just to add this component to my object, and that's all I need to do. And also, I created this drone move component. Remember, what do you think this component should hold right now? Just the data, right? Okay, so I open it, and you see, I extended Monobehaviour because I wanted to be able to attach it to my object, but right now I just have data. I don't have anything else, right? Which is important to what we are doing right now. The same goes to the helix rotate component. So you see here that I have just the rotation speed. I don't have anything else. I'm not transforming this data here. For transforming the data, do you remember what we're going to be using? Systems, right? The systems are the things that are transforming the data. So to create a system, now we need to interact with the entity's namespace. In this case, I'm no longer extending Monobehaviour. I'm extending the component system class. And let's skip this for a second. But now I have a new series of methods that I can hook, and Unity will start calling on itself, right? If it's a system. Okay, so I have this onUpdate, which is similar to the regular update that we all know and love, but it's now for the ECS world. Okay, so it's going to be called as far as possible. And now I'm just I'm getting a reference to the delta time, and here I'm creating a for each cycle, and I'm saying, okay, for all the entities that exist in the world, get a reference to its transform, and then transform its transform, right? Its position, sorry. Okay, so how does this system knows which objects to act on? This is the important part. And it knows because I'm telling, okay, get all the entities with this data. It's similar to a query, right? To a database query. So this data, it's a struct that contains a transform, and a drone move component. So what my system is going to do is going to act on all the game objects that are in the world that contains the transform component and the drone move component. Okay, doesn't matter if it's a drone or a cat or a car or a spaceship or anything. We don't care. We're going to transform all the objects with a transform and a drone move component. So I'll go back to Unity. I'm going to click play. It's moving. It's working. Let's see. Now the question is, who is kickstarting the drone move system, right? I'm not calling that from anywhere. All the systems that find something something that we're querying for, in this case, the transform and drawn move component, will get activated, will run through all the entities that we have, and it will simply work. Some sort of debugging function here is if I go to my, in this case, the drawn game object. If I go to the game object entity, you see that has a handy tool that tells me, okay, which systems are acting on this object. And you can see here that the only system that is acting over this set of data, it's the drawn move system. And you can see the query contains the drawn move component, the transform, and also the entity. But this entity is just by default because I use this script. Okay, so that's how it's working. Pretty simple. We get some benefits because on the coding side and on how easy it is to read this code for us humans, that sounds weird, is that we have separated our data from the code that transforms the data. So it's easier to read, and it's going to be faster. Right now, this hybrid approach is just a way for you to get used to the ECS way of programming in Unity. The goal is to at some point reach a pure ECS style of working, where every other Unity system, like I was mentioning, the rendering, the physics, the input, or whatever, it's ECS ready, so you actually see the performance benefits, right? So right now, this hybrid approach, if you want to go to the forums, if you want to grab the package and play around with it, it's mostly to get used to this new paradigm. But it's not by no means like the final thing that we're going to be working on, especially since, again, we don't have the entire Unity engine ECS ready yet. So let's just quickly move to the job system, which is another important thing. The job system and the ECS usually come together, like in Unity presentations or blog posts. But these two things are completely independent. You can use them together, and if you use them together, you will get like the best of the two worlds. But you can use the job system without the ECS, and you can use ECS without the job system. Okay, so what's the job system? It's a way for you to code multi-threaded code that it's safe and that it's simple. Have you tried writing multi-threaded code in the past? Well, some people. Usually it's hard, it's difficult to debug, it's a nightmare, and that's why many users end up not doing this. But we don't want like this to prevent users to writing multi-threaded code. Just one quick example. So there's also another package. This comes in another package, but again, you can use it independently from the ECS. In this case, I'm not using ECS at all. This is just a pure job system demo. You can see here, I'm creating a job just to add two objects, which is not super exciting. So you can see here that I'm exposing a float, A, B, and I'm going to add those values. The key part here, I don't have that nice laser. The key part here, and you probably will see this a lot, is the native array word. This means this is a new data type that we're putting, a new data structure that we're putting out there. What this means is this is going to be our link between Unity's code, scripting code, the code that you write, and the native code that Unity handles underneath, right? So this is a super fast way to interact with that native code. So yeah, that's basically what that means. I'm going to execute the job, and you can see that I'm saving the result in the position 0. It's weird, but yeah, it's an array, so I need to access it by an index. This is how you use it. The only important part here in reality is just making sure that you have a handle and that you can tell the job, or the job can tell you, okay, I'm done, and then we can dispose that thing, basically. Now that we think about jobs, and now if we're using ECS also, we have a nice memory layout that is like nicely independent from each other, so we can parallelize our jobs and our code. So this is the same thing. I'm just making my jobs parallel ready, right? In this case, the result, I'm not saving it at the position 0. I'm just saving it wherever the result should go. So it's the same thing. I tell the handle to schedule to the job to finish, and then I process the end. Lastly, the burst compiler. Have you heard about the burst compiler? Some people? Okay. I see less and less hands every time. Maybe you're hungry and you don't have energy to raise your hand. But yeah, burst compiler, it's just a concept. Well, it's not just a concept. It exists, but it's something that it's good for you to know that exists. But usually you won't have to mess around with it, right? The goal of the burst compiler is to take your C# jobs and create optimized native code for the platform that you are targeting to, right? That's its only purpose. You don't have to do basically anything else besides just indicating that you want to use, you want your game to be compiled with bursts. But besides that, you will be sure that that Unity is compiling the most optimized code for the target platform that you're going after. Okay, so that's it. I hope you had some fun. I hope you learned something new. This is something that it's not new for the world in general, but it's new for us Unity programmers. This is where we are envisioning the future of Unity going. So it's important for you to start getting a grasp, getting an idea of how these concepts work, how you can switch at some point to this paradigm. So yeah, that was the goal. So thank you very much. I'll be around if you have any other question, and that's it. Thanks.